Hey, good evening, everyone. Welcome to O-level physics lesson. Today is first day of school, Monday, 26th of June. How's your first day of school? Okay, and then we are going to start on the theory of the topic of energy. Okay, energy. Yeah, in the past, this topic name is longer. It's called work, energy, and power. Okay, but for your batch onwards, they have shortened the topic name to just energy. Okay, but to me, they are the same. Okay, so I will not show you all the mind map of the whole topic. I'm going to go straight into, okay, this is the last topic on the trend. Okay, this is the last topic, okay, on the section called Newtonian mechanics. Okay, after this, we'll be going into thermal physics. Okay, so this is the last topic of Newtonian mechanics. Okay, and let me share with you what you need to know over there. Okay, this is the learning outcomes that all of you need to know, okay, by the end of this topic. Okay, so there are three subtopic. Okay, there are three subtopic. There is the energy, okay, work, power, and efficiency, and energy resources. Okay, there's something new that you all need to learn will be part G lah. Okay, so there is number one, energy stores and transfer. Okay, so we talk about energy stores and transfer first. Okay, and that will be the first three part. Okay, this is the first three part. Okay, that's under energy stores and transfer. Okay, then when you talk about work, power, and efficiency, okay, it is the next three part. Okay, number two. And lastly, when we talk about energy resources, we are at number three. Okay, so you'll take about 2 minutes, read through what is the learning outcome, and then I will go through the learning outcome with you all. Okay, so let's begin. Okay, so I'm going to explain what exactly is the meaning of energy. Okay, so I would like you all to write this down because it's very important. Okay, energy is okay, let me write this down. Okay, so energy is a measure of the capacity to do work. Okay, it's a measure of the capacity to do work. Is how much you can use to do work. Okay, can you see over here? So energy and work are related. Okay, so energy is how much capacity there is to do actual work. Understand so far? Okay, so that is the first thing you need to know. Okay, and energy can be transferred from one store to another. Okay, where you can transfer from one store to another. Okay, so that is what you need to know. Okay, so if you ask your seniors or your teachers, they may not be very familiar with this word called store. Okay, when I see the word store, I also find it quite weird. Okay, so there are different type of energy store. Okay, there are different type of energy store. So what are the example? Okay, so I'm going to write down a few here. Okay, first of all, there is this thing called the kinetic store. Okay, there is the gravitational potential store. There is a chemical potential store, elastic potential store. Okay, internal store, as well as nuclear store. Okay, so energy store, there are 6 different store that you need to know. Okay, why do we use the word store? Okay, I think there's a change in the terms of science now. In the past, we will say that there is kinetic energy. Have you heard of this before? Kinetic energy? If you heard of that, give me a yes reaction. Okay, in the past, you have heard things like kinetic energy. Have you heard before gravitational potential energy, chemical potential energy, elastic potential energy, nuclear energy, and internal energy? So in the past, we use kinetic energy and so on. Okay, but now, okay, we do not say that. Okay, we do not say that. Instead of kinetic energy, okay, like in the past right now, in the past, we say that this is called the kinetic energy. Okay, so if you are familiar with kinetic energy, now, how do you say it? Okay, you need to say that energy in the kinetic store. Is that clear? Okay, so now you actually say energy in the kinetic store. Okay, so energy in the kinetic store is actually related to motion. Okay, so this one is related to motion. Understand so far? Okay, so anything that has motion will have energy in the kinetic store. Okay, so now, okay, if anything that's motion, we'll have this thing called energy in the kinetic store. So we don't use the word kinetic energy anymore. Okay, next. In the past, we will use things like number 2, gravitational potential energy. Am I right? So how do we say that now? Now we will say that it's the energy in the gravitational potential store. Is that clear? So anything that has a height, okay, will have this energy in the gravitational potential store. Are you all clear about this? Okay, is this something very weird? Because I find it very weird. But this is something new that you all need to know from your year onwards. Okay, the next one is chemical potential energy. Okay, so likewise, you write down energy in the chemical potential store. Is that clear? Okay, so what is this related to? It's related to chemical bonds. Okay, this energy is related to the chemical bonds. So far, are you all with me? Okay, now, elastic potential energy. That's what you learned last time. So from now on, you don't say that. You just say that this is energy, okay, in the elastic potential store. Okay, understand? So what is this related to? Stretchability of a material. Understand so far? Okay, so if you are very used to what you see here, kinetic energy, gravitational potential energy, okay, chemical potential energy, elastic potential energy, and so on. Okay, you need to tell yourself you need to change. Okay, you must say that it's energy in the kinetic store from now on. You must say there's energy in the gravitational potential store. Okay, energy in the chemical potential store, as well as energy in the elastic potential store. Okay, how many of you have learned this topic already? Okay, let me know. If you have learned this topic in school, give me a yes reaction. If you have not learned this topic in school, give me a no reaction. Siren and Zachary, how about you? Siren? Or Siren still in Sec 2, right? Okay. Okay, only Shixuan has learned this topic. So Shixuan, can you tell me, can you tell all of us, your school teach you kinetic energy or teach you energy in the kinetic store? Which term did your school teach you? Can you share with all of us? Which term did your school teach you? Oh, okay. So your school already started teaching the new thing. Okay, this is something that also very new to me. I also find it very weird. Okay, but that's good. Okay, so we have done the 1, 2, 3, and 4. Okay, what's number 5? Okay, internal energy actually is very similar to thermal energy. It's the same thing. Okay, it is due to the internal energy, and therefore there is thermal energy. Okay, so how much internal energy object has is related to how hot the item is. Is that clear? Okay, so the internal energy or thermal energy, okay, is the same as energy in the internal store. Is that clear? Okay, so what is this related to? It's related to the temperature as well as the state of matter. Okay, temperature and state of matter. Is that clear? Okay, so the internal energy of an item, okay, in the past we call internal energy. Now we call energy in the internal store. It is associated with the temperature as well as the state of the material. State means can be solid state, liquid state, and gaseous state. Okay, so today, okay, to the Rui Hong, Siren, and Zachary, I do not know what you all learned in the lower sec or in primary school. Okay, but I remember primary school we use the left side. Okay, in lower sec, what do you all learn? You all learn okay, in lower sec, what do you all learn? Can you all share with me in the chat? Okay, next one, nuclear energy. Okay, you just write down energy in the nuclear store. That's all. Okay, what is it related to? Okay, it's actually related to the stability of the nuclei in the atom. Understand? Okay, so all of you will need to know there are energy store. In this case, there are 6 energy store. Kinetic energy in the kinetic store, energy in the gravitational potential store, and then chemical store, elastic store, internal store, as well as nuclear store. Okay, this is just a definition, and all of you need to understand this. Okay, and from your year onwards, instead of kinetic energy and so on, okay, from now on, you will need to use in this term, energy in a kinetic store and so on. Okay, no more kinetic energy, no more gravitational potential energy and so on. Is that clear? Okay, then let's continue. Can you give me an example? Okay, one by one. Shixuan, Okay, let me write down. Zixuan, give me an example of energy in a kinetic storm. Okay. Then for Rui Hong, give me an example of energy in a gravitational potential storm. Okay, Siren, are you able to give me a example of energy in a chemical potential storm? And lastly, Zachary, can you give me an example of energy in a elastic potential storm? Example. So what is an example? Okay, so I can give you an example. Energy in the internal storm. Boiling water has energy in the internal storm. Does it make sense? Okay, so that's one example. Okay, then energy in the nuclear storm. Okay, a bit hard to explain now. Okay, but one example of energy in the internal storm could be boiling water. Or even ice also have energy in the internal storm. So I would like you all to actually give an example. Okay, so Zixuan mentioned energy in a kinetic storm. Zixuan says that bullet. Yes, bullet has motion. So bullet has energy in a kinetic storm. Well done. So besides bullet, we go another example will be your fan. Okay, your fan also has energy in a kinetic storm. Okay, now Rui Hong, any example of energy in a gravitational potential storm? Okay, Siren, don't use CPE anymore. That's the old way. Okay, use the new method. They use the new way of explaining the energy. Okay, Rui Hong says that plane. Yes, plane has a certain height. So plane has energy in the gravitational potential storm. Well done. Okay, another example is a book. Okay, a book that you place at a height. Okay, the book that placed at a height will have energy in the gravitational potential store. Well done. Okay, then Siren mentioned battery. Very good. Biomass. Well done. Yes, they are both examples of energy in the chemical potential store. So don't use chemical potential energy anymore. Okay, Siren, is that clear? Okay, use the term energy in the chemical potential store. Okay, Zachary says spring. Yes. Okay, but don't use the word EPE. You use the word EP store. Okay, energy, example of energy in the elastic potential store. Okay, don't use the word EPE. EPE is the old way of explaining. Okay, so Siren, well done.
Could you try again?
Every time I call Siren, my Siri will activate one. Do you face the same problem? Okay, so well done. So are you all clear about this? So examples of all these stores. So let me write down. Okay, it can be a fan, bullet. Okay, height can be a plane in the sky. Okay, chemical bond could be things like battery. Okay, and then this one could be a spring. Okay, so these are example of the store, energy of the store, energy store. Clear so far? Okay, up to here, are you all with me or are you all confused? Because this store thing is also very new to me. I don't know why they're using this term. Actually, the old term is also not wrong. Okay, they are still using the same term. Let me look at the textbook, what the textbook says. Wait, what the textbook tells me. Okay, from what I read in the textbook, the old way of explaining is still correct. Okay, just that we have this new term called the energy store. And I don't know why they actually use this new term. Okay, so what is new here is the term called energy store. Okay, and there are 6 types of energy store. Okay, up to here, any question? Okay, so first of all, we need to know energy is a measure of the capacity to do work. Okay, we will actually learn the definition of work in number 2. Okay, what is work? Okay, then you need to know that energy can be transferred from one store to another. In the past, we always say from one form to the other. Now we use the word store. And the next thing you need to know is there are 6 types of energy store. So these are the 6 ones that I'm mentioning now. Okay, next thing, energy. Okay, the energy, the short form for energy is capital E. And the SI unit of energy is joule. Okay, the short form for joule is capital J. Okay, so you all need to know this. Okay, energy, okay, is a capacity to do work or is required to do work. Okay, the SI unit for energy is joule. Okay, up to here, any question? Okay, one new thing that I want you all to actually understand. A little bit different here it is. Energy, just assume that energy is like your money. Okay, you need a lot of money to do work, for example. So what is a store? A store is like your bank account. Okay, so there are 6 types of bank account. Okay, so there is a kinetic bank account, there is a gravitational potential bank account, and so on. So inside the bank account, you can have money. The money is the energy. Okay, so let me change this. So this is your type of energy, and this is your stores. Okay, so your stores contains the energy. Is that clear? Okay, the stores contains the energy. Okay, the energy is found inside the store. Okay, so energy can be transferred from one store to the other. Okay, energy can be transferred from one store to the other. Okay, however, the total energy is constant. Okay, so you can transfer energy from one store to another, but the total energy is constant. Is that clear? Okay, the total amount of energy remain constant. Okay, there are 6 different kind of store. So energy can be transferred from one store to the other, but the total energy will be constant. Understand? Okay. Let me explain a bit of what is learned in the past. Okay, in the past, we actually learned, okay, that energy can be converted from one form to the other. Okay, that was the old way of learning. Okay, both methods are not wrong. Okay, but from your batch onwards, okay, what you all need to understand is energy, okay, actually using the energy store as a new way of model. Okay, so energy is transferred between the store. Okay, so that is what you are learning, okay, using this new model. So that's a bit of difference for what you are learning compared to what your seniors are learning. Okay, up to here, are you all okay? Okay, so now you are clear about the difference between energy and energy store. And this is something that you need to learn from now on. So let me move on to the next part. How can energy be transferred from one store to another? Okay, there are 4 different ways. Okay, I'm going to go through these 4 different ways. Let me go through the first way, the mechanical way. So for example, you have this car. You apply a force on the car. So at first, okay, it's moving 1 meter per second. After some time, because you're applying the force, it's now moving at 2 meter per second. Is that clear? Okay, so if you have learned in the past, because when they are moving, okay, they are moving, this car possesses kinetic energy. Understand? Is that clear? Okay, so at first, okay, the car has 1 kinetic energy, 1 unit of kinetic energy. Okay, but because it becomes 2 meter per second, if you have learned the kinetic energy formula, okay, which is can you see here? Kinetic energy formula. Your speed is square, right? So energy becomes square of it. Okay, so your energy now, when you're moving at 2 meter per second, is now 4 times more. Okay, it's now 4 times more. Okay, so there are now 4 times of kinetic energy. Okay, up to here, are you all clear? Are you all clear about this? Okay, so are you all convinced when it's moving at 1 meter per second, it has 1 unit of kinetic energy. But when it's moving at 2 meter per second, it has 4 units of kinetic energy. So what is the extra energy that you see here? Okay, there is extra 3 kinetic energy or 3 units of kinetic energy that is that this car actually now possesses. So these 3 kinetic energy come from where? Okay, these 3 kinetic energy come from where? Okay, so these 3 kinetic energy actually comes, these 3 units of energy comes from the force pushing the car over a distance S. Are you all clear? The force that pushed the car over a distance S contribute the 3 energy to this kinetic energy. Are you clear? Because at first, the kinetic energy is 1 unit. When it's moving at 2 meters per second, it has 4 units. So where does the 3 extra unit come from? It is due to the transfer. Okay, the energy are transferred mechanically Okay, the keyword here is mechanically by force over a distance. Okay, by this force over a distance. Is that clear? So this force over a distance produces this 3 unit of energy that produces the 4 unit of kinetic energy. Okay. By this explanation, are you all clear? If you are clear, give me a yes reaction. If you are not clear, give me a no reaction. Okay, Zachary and Siri understand. Rui Hong and Sishan. Sishan, is that what the school teacher teach you? Okay, so when the car is moving at 1 meter per second, it has 1 unit of kinetic energy. When it's moving at 2 meter per second, it has 4 unit of kinetic energy. So this extra 3 energy comes from where? This extra 3 unit energy comes from the force acting over a distance. Okay. It comes from the force acting over a distance, and it is transferred mechanically from the force acting over a distance to the car. Is that clear? So this 3 unit of energy comes from this force acting over a distance S and is transferred to the car mechanically. Okay, so far? Okay, so let's go to the second one. Electrically by electric current. How is energy transferred? Okay, electrically. Okay, so we do a simple circuit that you all learn in primary school. We have a battery with a bulb and a switch. Can? Okay, so as we have mentioned before, the battery itself has energy in the chemical potential store. Okay, it actually contains chemical that will actually react, and that result in a current flowing in the circuit when it's closed. Is that clear? Okay, so what happened at first when it opens? When the circuit is open, okay, when the circuit is open, we have energy itself. Is it? So we have this thing called the internal energy. So the bulb has a temperature. Okay, it is a solid state. So maybe there's 1 unit of energy, of internal energy. Is that clear? Okay, then this energy in the CP store, okay, the battery itself, it actually contribute 4 unit of energy to the bulb. Okay, to the bulb. Okay, so 4 unit of energy is given, okay, from the battery, okay, to the bulb. Clear? Then the bulb actually give out 2 unit of battery of energy, okay, as light and infrared, which is heat. Okay, so the bulb itself produces, okay, the bulb itself, after getting 4 units of energy from the battery, it actually give out 2 units of energy, okay, as light and infrared. Okay, then what is the resultant internal energy of the bulb? So you got 1, you plus 4, you minus, okay, you plus 4, you minus 2. Okay, in the end, your bulb, when it's light up, okay, it has 3 units of energy, of internal energy. Okay, why is it greater? Okay, why is it greater? Okay, basically because the temperature of the bulb increases. So therefore, the internal energy now is 3 units compared to 1 unit when it's not being closed circuit. Are you clear about this? So at first, the bulb has an internal energy of 1 unit. Then the battery itself, okay, the battery contribute 4 energy to the bulb, okay, of which 2 energy is given out as light and heat. Okay, so then the remaining 2 energy will now be contributed to the internal energy of the bulb. Okay, so because the bulb now will have a higher temperature. Okay, so therefore it has a greater internal energy. Are you clear about this? Okay, so how is the energy transferred from one store to the other? Okay, so in this case, 4 units, can you see here? 4 units of energy is transferred electrically from the potential store of the battery, okay, to 2 units of energy transferred by light and infrared to the surrounding. And at the final state, you will have 3 units of energy. Is that clear? Okay, so there's an overall increase in the energy in the internal store of the system. Okay, I repeat. Initially, there is 1 unit in the energy in the internal store of the system. Okay, the bulb itself has 1 unit of energy in the internal store. The battery produces 4 units of energy in the chemical potential store. So these 4 units of energy is transferred electrically, okay, by electric current, okay, into the bulb itself, okay, of which 2 of the energy are transferred out of the system by light and infrared wave. And then there's still 2 more unit of energy that is being retained. So overall, the bulb has an increase in energy in the internal store of this system. The system is the bulb. Yeah, I explain until I also blur, but you understand or not? Okay, if you understand, give me a yes reaction. Okay, if you understand, give me a yes reaction. If you don't understand, just let me know. Okay, I try again. Rehol, Zachary, are you okay? Okay, so the bit different thing is this new thing called the store. This is the new thing. The new thing. Okay, so now we're going to talk about transfer by heating. Okay, by heating. So let's see this one. Okay, so we have a pan, and then we are going to melt a butter. So this is the butter. At first, I think every time I explain a scenario, my explanation should be improving, right? Okay, energy, internal energy of the butter, 1 unit. Clear so far? Okay, so at first, before you heat up the butter in the cooking pan, the butter itself contains, okay, has 1 unit of energy in the internal store. Are you all clear? Then I put fire here, fire. My fire contribute 5 unit of energy. Okay? 5 unit of energy. Then what happened to your butter in the end? If all this energy is being conducted to the butter, okay, this internal energy of the butter will increase. Clear so far? So instead of 1 unit, you will get 6 unit. Okay, so this is the original 1 unit. This is the internal energy. Okay, this is the fire. The fire will actually contribute 5 unit of energy. So your butter now, after fire, has 5 unit of energy is transferred by conduction from the fire to the pan to the butter. And then only in heating, a transfer will take place when there's a temperature difference. So it only takes place from a higher temperature to a lower temperature. It will never happen where thermal energy can move from a lower temperature to a high temperature. It's always due to a difference, and it's from a higher temperature to a lower temperature. Okay, so this fire and the pan, the hot pan, produces 5 units of energy that is transferred from the pan to the butter due to the temperature difference because of heating. Okay, so far? And because of that, the system, the butter system itself, okay, the energy in the internal store of this system increases and becomes 6 units. And this increase is due to an energy transferred, okay, by heating, okay, from the pan to the butter due to a temperature difference. I repeat myself again. This is the system of the butter. So there is an increase in the energy in the internal store of the butter due to the energy that is transferred. Okay, that is transferred by heating from the pan to the butter due to a temperature difference. Are y'all with me? Because I'm getting a bit confused myself really. I repeat myself, Okay, I repeat myself, there is an increase in the energy in the internal store of this butter, this butter, due to the energy that is transferred by heating from the hotter pan to the cooler butter due to a temperature difference. Are you okay with that? Okay, so let me repeat the first example, number 1. Okay, number 1 is the car, remember? So let me repeat. The car system has an increase in the energy, okay, in the energy in its kinetic store, okay, due to the mechanical force or the work, due to the mechanical work done by the force acting on the car over a distance s. Are you all clear about this? Okay, so the increase in the energy of the kinetic store of the car is due to the mechanical work done by the force acting on the car, okay, over a distance. Clear? Okay, now we go back to the electricity, the bulb. Okay, so the bulb itself, the bulb has an increase in the internal energy store due to a transfer, okay, transfer electrically, okay, electrically from the potential chemical potential store of the battery to the system. Then two energy is being transferred out as light and infrared, and then there is an overall increase in the internal energy, internal store of the bulb system. Are y'all with me? Y'all see what I'm trying to say? Are y'all okay? Yeah, I'm getting a bit crazy already, because it's something very new to me. Okay, hopefully it's something not that new. You all learn this for the first time. Because for me, I must unlearn and then relearn. That can be very scary. Okay, now the propagation of wave, there's two types. There's an electromagnetic. I think today we just talk about energy store and transfer, enough already. We'll just talk about this A1, A, B, and C. Okay, how do we transfer energy by propagation of wave? Okay, so let's say you all are playing in the field. Okay, you are playing in the field. Okay, so at first you're not so hot, right? So your internal energy, one internal energy. Okay, so far in the field where there is a sun. Okay, so the sun will actually transfer maybe 2 unit. Okay, the sun maybe transfer 2 unit of energy to you when you are in the field. Okay, so after a while in the field, you will get 3 unit of energy, of which 2 are from the sun and 1 is your original internal energy. Okay, so you become hotter lah. Okay, because you're standing in the sun, playing in the sun. So how do I explain this? Okay, how do I explain this? Okay, so I explain this. You have okay, let me explain again. There is an increase. Can you see there's an increase? Okay, there is an increase in the internal, increase in the energy in the internal store of you. Okay, I repeat myself. There's an increase. Can you see here? There's an increase in the energy in the internal store of this boy, due to the energy transferred from the sun, okay, to the boy, okay, by the propagation of an electromagnetic wave. In this case, this electromagnetic wave is the infrared wave. Clear so far? Infrared. Therefore, it becomes hotter. So I repeat myself again. This boy has an increase in energy in the internal store due to the energy transferred by the propagation of the infrared wave, which is an electromagnetic wave. Are you all clear about this? Okay, I've now given you 4 examples of how to use this store transfer and energy, and how to use this new model to explain energy transfer. Are you clear about this? Okay. Now another example. Okay, so now we are going to play a drum. Okay, you're going to play a drum. This is a drumstick. This is a drum. So you're going to play a drum. So before you hit the drum, okay, before you hit the drum, is the drum moving at all? The drum is not moving at all. Okay, so the energy in the kinetic store of the drum is 0. Is that clear? Okay, then once you hit, yeah, sorry, let me just change something. Okay, now we talk about this system. This system we are talking about the eardrum. Okay, but still the drum is still here, but what we are drawing here is when there's no sound, your eardrum will have no kinetic energy. Clear so far? Then when you hit the drum, okay, you hit the drum will contribute some energy, okay, to your ear. Okay, then now your ear will have the same energy here. Clear so far? Okay, so how do I explain this? So the energy in the kinetic store of your eardrum, okay, will gain energy, okay, due to the energy transferred by the propagation of sound wave. Okay, when you learn about sound wave, you know that sound wave is a mechanical wave because the air particle actually moves. Okay, so let me repeat myself again. The increase in the energy store or the increase of energy in the kinetic store of your eardrum is due to the propagation of wave. Okay, it's due to energy transferred by the propagation of sound wave or mechanical wave. Okay, from the hitting of the drum. Are you with me? Okay, so the key point you need to write is like this. For example, you write like this. Increase in energy of what store is due to energy transferred by which of these? Energy transferred by 1, 2, 3, or 4. Is that clear? 1 to 4. Okay, one of these reason. Okay, from what store? From where? So in this case, it's from the hitting of the drum. Okay, so it's due to the energy transferred by propagation of sound wave, okay, from the hitting of the drum. Is that clear? I know it sounds a bit funny, but that's the new model that you are required to learn. Okay, maybe you'll give me some feedback. this store thing and the transfer of energy by this 4 method, okay, and due to the store, how much you understand? Tell me. 0% means you don't understand at all. 100% means you understand very well. Okay, tell me how much you understand. For me, I understand like 70% or maybe 60. How about for you? How well you understand what I've talked about so far? Okay, Zixuan is 90%. How about the rest of you? Zachary 70, Siren 75, Ray Hong 60. Okay. You all can tell that I'm also struggling to explain the new manner, right? Okay, let me explain a bit more using the primary school method and then convert it to the new Sec 3 method. Hold on. Okay, so let me show you something. When you leave a hammer and then you hit down, in primary school, we will say that there is a lot of gravitational potential energy convert to, okay, when it's moved down, it'll be moving very fast, right? You will be getting a lot of kinetic energy. Okay, so that is what you learn before in primary school in lower sec. Okay, so the gravitational potential energy of the hammer has been converted to the kinetic energy of the hammer.
What would you like to convert?
Okay, so now in Sec 3, how are you going to say this? Okay, at first, okay, there is still GPE. Maybe there is 3 unit. Okay, there is 3 unit. Okay, then as you push the thing down, you're not letting it drop. You're also forcing it down. So your hand actually contribute a force, okay, of 1 unit, okay, to the hammer. Is that clear? Okay, so your hand actually, because your hand is pushing the hammer, so your hand actually has a force of 1 unit of energy on the hammer. Clear so far? Then your kinetic energy now is all 4 unit plus the 1 unit of the hand energy. So how do I explain this? Okay, how do I explain this? Let me explain to you all. So this is the green extra. Okay, originally is 4 unit of GPE, and they all convert to 5 unit of KE. Okay, so in the past, you will say that the hand produce work of 1 unit of energy plus the 4 unit of gravitational potential energy will produce a total of 5 unit of kinetic energy. Now, in Sec 3, using this new model, how do I explain? Okay, at first, when the hammer is not moving, there is energy in the gravitational potential store, okay, of the hammer system. Is that clear? Okay, KE is 0. It's not moving. So KE is 0. 0, nothing. Okay, so there is energy in the gravitational potential store of this hammer. Is that clear? Then your hand pushes the hammer down. So the hand actually contributed a force, okay? Okay, so your hand has a force of 1. Okay, yeah, okay, sorry. Your hand has a force pushing the hammer over a distance. Okay, over a distance. Okay, so your hand produced some work. Is that clear? Okay, so 1 unit of energy is transferred. Okay, out of the 4 reasons, you choose the first reason, is transferred mechanically. Okay, due to the work done by the force of the person's arm in driving the hammer over a distance. Are you clear about this? Okay, so 4 units of energy in the gravitational potential store is being and plus 1 unit, okay, plus 1 unit of work done due to the plus 1 unit of energy transferred mechanically due to the work done by the force of the hand on the hammer over a distance will result in the total increase of the energy in the kinetic store of the hammer. Are you all with me? So now, have your percentage increased a bit or not yet? Okay, so so basically what's happening now is that we are all explaining the energy in the past, right, as energy store. Okay, so now we are going to go into part B. Okay, this part A, we'll see moving forward, we'll see how it goes. But let's go to part B. So how are we going to calculate the size of an energy store? So down here, there's 2 types of energy store that you need to know. Okay, so there's EK. Okay, EK and EP. Okay, so EK is energy in the kinetic store. Okay, energy in the kinetic store. And then EP will be energy in the gravitational potential store. Okay, so these 2 energy, the formula has not changed from last time to now. But instead of saying kinetic energy, we now say that this is energy in the kinetic store is equal to half mv squared. Okay, this is the formula that you need to remember. So can you imagine when your velocity of your mass doubled, when this V double, your energy in the kinetic store will be 4 times bigger. Because when V is 2, 2 squared is 4. So when your velocity triple times 3, 3V squared, your kinetic energy actually times 9. Are you clear about that? Okay, so this formula shows that the faster you are going, the much bigger your energy in the kinetic store will be. Are you all with me? I repeat, as your mass, as the velocity of your mass increases, the energy in the kinetic store increases much more. Are you all with me? Because of this square to the V. Okay, because the V, if it's 2 times the V, this 2 becomes 4. If the V is 3V, this 3 becomes 9. Okay, so this energy is always, okay, if I were to draw a graph of V versus energy. Okay, it will be always like that. You increase a bit, energy increase a lot more. Can you see that? Your speed increase a bit, your energy increase a lot more because of this V square, this V square relationship. Are you clear with, are you with me? Okay, then the formula of the energy in the gravitational potential store, okay, the formula is mgh. So the higher your item is, the greater your energy in the potential store is. Your mass shouldn't change. Your gravitational field strength shouldn't change much. So if I were to increase my height, my energy in the potential store should be a straight line. Okay, the higher you are, okay, your energy in the potential store will be directly proportional to your height. Are you clear about this? Whereas for the EK is different. EK and the V, it is this manner. The relationship is like this. So a small increase in V result in a big increase in the energy. Are you all with me? Okay, so these are the two energy formula that you need to remember. Okay, so when we do go through example questions, okay, you need to use these two energy to solve. Clear so far? Okay, the last thing that we're going to go through today, I promise you today I just go through this. And I take a long time because it's something very new to me. Okay, the last thing I'm going to talk to you is the principle of conservation of energy. I will just tell you the principle and just one example, and that's it for today. Okay, so this principle states that energy cannot be created or destroyed. Okay, you cannot create energy or and you also cannot destroy energy. Okay. However, energy can be transferred from one store to another. Okay, the total energy of an isolated system is constant. It shouldn't change. Are you with me? Okay, so we talk about a system, maybe the hammer. Okay, energy cannot be created or destroyed in the hammer. It can only be transferred from one store to another. Okay, the total energy of an isolated system is always constant. Okay, you cannot create, cannot destroy. It can only be transferred from one store to the other. Are you clear about that? How to transfer? Only these four methods. Okay, only these four methods. Okay, these are four methods of transferring. Okay, how many stores are there? There are 6 stores that you learn. Okay, how to transfer energy from one store to the other? Only these 4 ways. Okay, mechanically by a force, by work done on a force, electrically by a current, heating due to the temperature difference, and propagation of wave by electromagnetic wave or mechanical wave. Any wave, okay, you can also do a transfer of energy between stores. Clear so far? Okay, so I would like you, okay, so in my acid question, okay, my acid question, I'll ask a few things. I'll ask a few questions. So you all better get ready. I'll ask you all, what is the principle of conservation energy? I'll ask you the formula of the energy of kinetic store, energy of gravitational potential store, okay, as well as the definition of energy. Okay, that will be a few acid questions I have for you. Okay, so for a start, let's begin. Okay, so these are the acid questions I have. What is energy? To What are the 6 types of energy store? What are the 4 ways of energy transfer? Okay, what is the formula of energy in the kinetic store? What is the formula of energy in the gravitational potential store? What is the conservation of energy? What is the principle of conservation of energy? Okay, 7. How much you learn today? How well Mr. Chu teach today? Okay, so start giving me this 8 essay question. Once all your 8 questions are done correctly, I call your name and you can read. Okay, Siren, your velocity should be small v. Okay, Siren, you may go. Zachary, your definition of energy is not correct. Number two, Zachary, you shouldn't use energy anymore. You should use energy in a kinetic store. You know, I just write kinetic store. Energy in a gravitational potential store. So the way you write the energy for question 2 is incorrect. Okay, number three, radiation is not correct. The third way of doing is is by propagation of wave. Okay, not by radiation. Radiation is one of the two method of propagation of wave. Can? Okay, Zachary, 4 and 5 correct. And number 6, energy can be transferred from one store to another, not object, from one store to another store. Okay, Zachary, are you clear? If you are clear, you may go. Okay, Ray Hong. Number 1 correct. Number 2 correct. Number 3 correct. Number 4 is not correct. It's not square of the mass of the object velocity. That's not correct. Okay, number 5 is correct. Okay, number 6 is correct. So Ray Hong, can you rewrite your formula for the energy in the kinetic store? Okay, Shishan, number 1, okay. Shishan, number 2, can you rewrite? I don't want to see nuclear energy and so on. I want you to write down. I want you to write down energy in the nuclear store, energy in the internal store, and so on. Okay, there is no thermal energy. There's no sound energy. There is no radiant energy. Can you rewrite? Okay, number 3, Shishan, the radiation is not correct. Okay, it should be by propagation of wave, not by radiation. Okay, 4 and 5 is okay. Number 6 is not complete. Number 6 is energy cannot be destroyed or created. What else? It can be transferred from what to what? And then the total energy in the system is what? So can you be more specific? Okay, Ray Hong, you may go. Okay, Shishan, you okay? Zachary, are you there? Oh, Zachary, you're done. Yeah, Shishan, just improve on the answer and then you're done. Okay, thank you, everyone.